Okay, this is Algebra 1, Semester 2, Unit 7, the very last section, 11.2, Simplifying Radical Expressions. And the movie cut off early, and some of you may want to see these, so I wanted to make sure and get them on. So, this is page 9 of those notes. Here we're simplifying again. I would probably go ahead and reduce that 20 and 14. 2 will go into both of those, so that would be 10 over 7. Now if you picture this, you've got 3 b's up on top and 1 b below, so I would go ahead and cancel one of those, leaving b squared on top. Now, as you go to simplify this, your b's, because you've got 2 b's, if you picture that, b times b in there, they could come out of that prison. And so we would have b radical 10 up on top. On the bottom we have radical 7. We cannot have a radical on the bottom, so you do need to rationalize that denominator. Again, we do that by multiplying radical 7 over radical 7 so as to create 2 of them in prison down here on the bottom. When you have 2 in prison, you lop them off, bring 1 out, and we end up with b, and then go ahead and multiply the 7 times 10 on the inside. That's 70. We know that nothing can come out from the prison because 7 is prime and 10 would be 2 times 5, and so there's not going to be any twins in there. Okay, last one here. We have radical 12 over 11b, and we could split these up. Radical 12 over radical 11b. We have a problem. We can't leave that as our answer. Number one, there's a radical expression in the bottom of the fraction, in the denominator. Also, that 12 could be broken down some. So let's go ahead and break down the 12, and that would be 4 times 3. 4 breaks down to 2 and 2. So the 2's will get out. We'll have a 2 outside of prison and a 3 left in. Now it's still over radical 11b, which we need to take care of that by multiplying radical 11b over radical 11b, so as to get this one out of prison. That way on the bottom in the denominator we have 11b. In the top we have the 2 outside of prison. Then go ahead and multiply the 3 times 11. That would be 33b inside of the radical. Okay. Next problem. It says, can you combine like terms when radical expressions are involved? What you're looking for is that the radical is the same. So here we have 2 radical 3 and a 6 radical 3. Rewrite those using the commutative property so that they're close together. I do ask for you to do that step. On this step, you're not required to show this work, but I'm going to show it to you. What you're doing is you're factoring out that radical 3 out of each of those, and then you would have a 2 plus 6. So you just factored it out, brought it to the outside, and put 2 plus 6 of what's left, then plus 4 radical 5. 2 plus 6 is 8, radical 3, plus 4 radical 5. You can't combine those two because the radicals are not like terms, and you would have to multiply before you could add. Here we go on this one. We've got a term here and a term here that need to set side by side, and this term need to set side by side. So however you want to do the commutative property so that you get those located, this is 1 radical 23 plus 4 radical 23 plus 5 radical 11 minus 7 radical 11. 1 plus 4 times radical 23, factor that 23 out of those, plus 5 minus 7 radical 11. So 1 plus 4 would be 5 radical 23. And 5 minus 7 is a negative 2 radical 11. Now, it appears as though we could do nothing with this one because they aren't like terms. And I caution you, when it appears that way, make sure that you can't get anything out of prison. When we see that, we factor this down. We've got 3 times 25. And 25 is 5 times 5. So if we look closely at that, we've got a 3 times 5 times 5. Those 5s can get out of prison. So we have 5 radical 3. In this one, 27 is 3 times 9. I should have circled those primes there. 9 is broken down to 3 times 3. So essentially we've got 3 3s underneath the prison, and it takes 2 to get out on a square root, so it's 3 root 3. Bring down this plus that we were adding between them, and we can see we have a 5 plus 3 times radical 3, so it's equal to 8 radical 3. So really look for all possible ways to reduce and to simplify before you just say that there's no changes. So here we have 28, which can be broken down to 4 and 7. 4 can break down to 2 and 2. Those 2's will come out. So we have 7 times 2 on the outside of that, and then the radical 7. Okay? 7 times 2 is 14, radical 7. We can bring down this radical 7. So we have plus 1 radical 7. That'll be 1 plus 14 times radical 7. And now let's see if this breaks down. We have negative 2 out front, then radical 63. Sorry, I didn't really break it down yet. Now we'll break that down. It would be 7 times 9, and 9 is 3 and 3. So we have negative 2 radical 3 times 3 times 7. Well, the 3's will come out. Negative 2 times 3 radical 7. That would be a negative 6 radical 7. So if we bring it over here with these, we have a minus 6 radical 7. And so we can just expand what we factored out here. We had a 1 and a 14, now we have a minus 6, all times radical 7. 1 plus 14 was 15, minus 6 is 9, radical 7. And there's your final answer. Okay, the last problems here. All that they're wanting us to do is distribute with radical expressions. Before I distribute, I always simplify if I can. This 12, as you've seen in previous problems, can be simplified. It's 4 times 3, and 4 is 2 and 2. So radical 2 times 2 times 3, the 2's could come out, and we would have 2 radical 3 in place of that 12. So to rewrite it, it's 5 radical 3 plus 2 radical 3. So it's up to you whether you go ahead and you add those before you multiply by that 5. That would be your order of operations. So 1 radical 3 plus 2 radical 3's would be 3 radical 3's times 5. Now, you can only multiply outside to outside of prison. You can't multiply outside to inside. And really, this is just one number here. So it's not like when you had to draw the arrow and distribute to both items because of the plus. There's no plus in there. So it becomes 15 radical 3. Final answer. Here, we can't simplify either of those radicals any further, so we distribute. You can't multiply inside of prison to outside, so the 2 remains the same, but the 2 on the inside does multiply by the 5, so it's a radical 10. Radical 5 times radical 5. Well, if you think about that, that's going to be a perfect square. So we have 2 radical 10 minus 5 plus 12. These two are like terms that we can combine. So we get 2 radical 10 plus 7. Again, if I go a little bit too fast for you, please pause the video and catch up with the notes. That's why I've put them on video, is for you to take the time that you need for these. Okay, it says the value of cube root of 55 is between which two integers? Well, cube root, remember I gave you the list to memorize at the beginning. It means that it's 3 numbers multiplied together. So 2 times 2 times 2 is 8. The cube root of 8 is 2. That 3 really means, if we think about our prisoners, it means that it takes 3 to get 1 out. So the cube root of 8 is 2. So I would go through and write what these cube roots are. 2 and 3, the cube root of 8 is 2. Cube root of 3 is 27. Well, the cube root of 55 doesn't set between those. So we know that that one's not a good answer. Cube root of 3 is, or I mean not cube root of 3, the cube root that equals 3 is cube root of 27. And the cube root that equals 4 is cube root 64. Now we do see that 55 is between 27 and 64. So B would be our answer. That's a great standardized test question. It says, which answer shows the expressions ordered from least to greatest? Well, the first thing that I would do here is I would reduce the ones that I can to their perfect roots. So the cube root of 64, we've already discussed, is 4. 2 doesn't need to be reduced. Cube root of 27 is 3. And the cube root of 100 we don't know because it's not a perfect cube, but we do know that the cube root of 125 equals 5, and the cube root of 64 is 4. So we know that this is a little bit over 4. So to put them in order, we'd have 2, and then cube root 27, because that's 3. Cube root 64, so that's 4. And then the cube root 100, that would be out here on the end. So we look at these, that one doesn't have the cube root on the end, mark it out. That one doesn't have cube root on the end, so mark it out. Cube root of 100, I mean. This one does have cube root of 100 on the end, this one does too. So we get the next smallest is cube root 64. It happens on C, it doesn't on A. So C is our choice. In math, multiple choice, you are always best off to eliminate the wrong answers. Simplify the following cube roots. Now this time, the prison rules are that it takes 3 to get 1 out. That's why that little 3 sets up there. So we factor this down, 25 and 10. 25 is 5 and 5. 10 is 5 and 2. Put that back in the prison, saying it takes 3 to get out. Those 3 5s get out as 1. We leave the 2 in prison. Don't forget you have to label your prison rule. So it's 5 cube root 3. Here we have 54 times 20. I would not multiply those, I would break them down. 6 and 9, that's 2, 3, 3, 3. This 20 breaks down to 4 and 5. I'm going to go ahead and drop the 5 down here. The 4 breaks down to 2 and 2. The reason I dropped the 5 down there is that it's prime, and I wanted to put it all back inside that prison. Takes 3 to get 1 out. I see 3 3s, so we get a 3 out. I see 3 2s, so we get a 2 out. And now the cube root, the rule of the prison, sets like that. and we still have to leave a 5 in there. Do one more step of simplifying by multiplying 2 times 3, that's 6. Cube root 5. Okay, cube root of 72, that's 8 times 9. 2 times 2 times 2, and 3 times 3. Now let's expand our variables. There's 4 x's, so we have x, 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 and there's 6 y's. 1, 2, 3, 4, 5, 6. Now put them all back in prison. It's a cube root, so it takes 3 to get one out. We have 3 2's right there. That comes out as a 2. There's only 2 3's, so we go ahead and put the 3 back in prison. 3 times 3 stays in prison. Now, there are 4 x's, so 3 of them come out as 1, but one of them has to stay in there. There's 6 y's, so 3 come out as 1 y, and another 3 can come out as another y. So our final answer is 2xy squared radical 9x. Don't forget to put that little cube root back in there telling us what the rule of that prison is. Last one, cube root of 1/8. I'd simplify by making that cube root of 1 over cube root of 8. We know the cube root of 1 is 1. We know the cube root of 8 is 2. Don't have any radicals left on the bottom, so we're done. Thank you very much. Study those problems and make sure you're ready for the test.